February 2026. Eastern Mediterranean. The ocean offers no comfort. It is neither a sanctuary nor a stage for blind heroism. It is a cold, unforgiving buffer zone, strictly governed by mathematical constants, fluid dynamics, and the laws of thermodynamics. At this precise moment, the United States Navy anchors the most expensive and complex machine in the history of human warfare in these waters. 100,000 tons of nuclear-powered forged steel, the USS Gerald R. Carrier Strike Group 12. It doesn't merely float as a ship, but as a sovereign island of American industrial power, projecting absolute lethality across a hemisphere. Welcome to Border Watch Daily, where we decode the military strategies of the modern world. But projection demands reach, and that reach is dictated by geometry. Observe the tactical map. Examine the raw geometric coordinates. The primary objective of this carrier strike group is not on a contested beachhead or a shallow coastal plateau. The target is not on the coastline. The enemy is the Islamic Republic of Iran's integrated air defense system. S-300 PMU-2 and Bavar. 373 missile batteries, deeply buried, lie hidden in the rugged fault lines of the Zagros Mountains, protected by millions of tons of natural rock and earth. The distance between the CVN-78's flight deck and this interconnected wall of radar energy is staggering. It exceeds 2,300 kilometers. This is the ultimate tactical paradox facing the carrier strike group commander. Look up at the flight deck of this supercarrier, stretching across approximately 18,000 square meters. Despite the ship's $13 billion cost, you won't find a single fifth-generation F-35C stealth fighter on it. The primary kinetic weapon of this carrier strike group is the FA-18E and F Super Hornet, a legacy platform, an undeniably capable fourth-generation aircraft, but bound by a strict thermodynamic reality. It has a maximum combat radius, at full load, of approximately 926 kilometers. What happens when the ultimate symbol of American power is seemingly crippled by the sheer scale of geography? If the enemy knows the exact physical limits of your internal fuel tanks, how do you break the equation before it breaks you? How do you annihilate a threat firmly beyond your physical reach when every available weapon seems to fail before reaching its target? Outdated, muscular 20th century doctrines would tell you to simply push forward and accept attrition. The logic of yesteryear would demand that you line up thousands of kilometers of flying gas stations, exposing enormous vulnerabilities in the sky, and order your aviators to fly straight into the maw of enemy surface-to-air missile rings, relying only on speed and electronic jamming. Today, we reject this suicidal mathematics. Blind courage does not generate lift. Bravery does not alter the ballistic trajectory of a Mach 6 interceptor, nor does it magically create fuel in an empty tank. Instead, we will dissect how United States Navy engineers and tacticians have deconstructed their machines to reassemble them into a distributed lethality network. The weapon is no longer just the explosive warhead. The weapon is the network. If you are proud of the cold and relentless mathematics of American naval supremacy, let us know in the comments. Before we design the solution, we must autopsy the constraints that make this mission seem impossible. The primary enemy in this theater is not the Iranian Revolutionary Guard or its fortified bunkers. The enemy is the mathematics of aviation. The enemy is physical friction. Let's start with biological friction. A machine can be refueled, but a human operator cannot simply be rebooted. The USS Gerald R. Ford did not leave its home port of Norfolk, Virginia, with a fully rested crew. It was abruptly redirected from a high-pressure, fast-paced deployment in the Southcom area of operations. The 4,500 American sailors on board had been floating in a steel box for over 237 consecutive days. The A-1B nuclear reactors can operate for 50 years without faltering, generating unlimited power regardless of the hour. But the human nervous system has a hard, unyielding limit. How long before the human operating system collapses under the weight of thermodynamic exhaustion and disrupted circadian rhythms? You cannot demand concentration when the brain is at the brink of fatigue, and adrenaline can only mask the degradation of fine motor skills for a limited time. And yet, time is running out. The geopolitical landscape has shifted, erasing the luxury of a delayed strike. National Reconnaissance Office satellites, positioned in low Earth orbit, LEO, have just transmitted Category 1 intelligence directly to the carrier's intelligence center. Deep within the Zagros Mountains, Iranian strategic forces are injecting highly volatile liquid propellant into a volley of medium-range ballistic missiles. Liquid fueling is the final, irreversible step before a strategic launch. The countdown to launch authorization is estimated at precisely 4 hours. If the Ford cannot systematically dismantle the air defense network protecting these silos to allow for a deep strike, the entire theater of operations will ignite. The stakes are absolute. But forcing this strike introduces the paradox of the sortie generation rate. To overwhelm the Zagros air defenses and secure airspace for heavy bombers, the Ford cannot simply send a handful of jets. It must unleash its assault tempo, meaning 270 relentless combat sorties in a single 2-4-hour cycle, designed to physically drown the enemy's detection capability. Calculate the demands of this requirement. The cruising speed of a fully loaded Super Hornet, battling the atmospheric drag of its external fuel tanks and heavy armament, is approximately 830 kilometers per hour. A round trip of about 4,600 kilometers equates to a continuous flight time of nearly 6 hours per aircraft. In the highly synchronized environment of carrier operations, turnaround time is paramount. You cannot mathematically achieve 270 sorties per day if your primary assets are absent from the deck for a quarter of the day. If a jet is in flight for 6 hours, it is not being refueled, rearmed, or inspected by the deck crew. The flight deck lacks aircraft. The laws of logistics categorically deny the possibility of such a sustained pace under these geographic conditions. And if your solution is to involve the U.S. Air Force in the fight by positioning KC-135 Stratotanker, refueling aircraft near the Iranian border to extend the Hornet's range, you enter the tanker kill zone. These tankers are vital, but their radar cross-section shines like a supernova on early warning radars. The enemy doesn't need to engage in complex air-to-air combat with agile naval fighters. The enemy simply shoots down the flying gas station. If the tanker falls, the entire strike group is immediately deprived of fuel, forcing them to ditch into the ocean. It's a failed equation. The 4-hour countdown continues to tick. To win, the Navy must fundamentally rewrite the laws of aerial warfare. When your physical arm is too short to reach the enemy, you don't try to stretch it beyond its breaking point. You detach it entirely. This is the mechanical heart of NIFC-CA Doctrine, the Naval Integrated Fire Control Counter-Air Doctrine. To survive in a highly contested, anti-access area denial environment, the United States Navy removes the concept of the fighter in this theater. The F/A-18E and F Super Hornet is stripped of its traditional air combat role. It becomes ruthlessly industrial. It is a missile truck. Its sole purpose is transport. The cargo it carries is stealthy kinetic energy, designed to be released well outside engagement zones. This is the standoff strike weapon, the autonomous, stealthy air-to-surface missile AGM-158BJASSM-ER, Joint Air-to-Surface Standoff Missile, extended range. Its effective range exceeds 926 kilometers. It replaces human vulnerability with radar-absorbing composite materials and cold computational processing power, ensuring that the most dangerous segment of the flight profile is performed by a machine, not a human pilot. But intelligence and extended range come with a severe weight penalty. The laws of aerodynamics demand a massive amount of kinetic energy to achieve lift with such a payload. How do you launch a missile truck weighing approximately 30 tons from a runway of about 90 meters? You cannot rely on the violent, inconsistent jolt of traditional steam catapults, which risk tearing the heavily loaded airframe deep within the hull. The two A-1B nuclear reactors pump a staggering 13,800 volts of electrical energy into the ship's grid. This power feeds the Electromagnetic Aircraft Launch System, EMALS. Linear induction motors discharge 121 megajoules of stored kinetic energy, applying a tightly controlled, closed-loop acceleration profile. It calculates the exact mass of the Super Hornet to the gram to ensure the airframe is not subjected to mechanical tearing, providing a perfectly smooth transition from deck to sky. However, a successful launch only solves the lift equation. The fuel solution demands safe zone logistics. Instead of pushing vulnerable assets into contested airspace, Air Force KC-135 Stratotanker refueling aircraft establish an orbital refueling track directly over the Mediterranean Sea. They loiter in an envelope of absolute safety, permanently protected by the Ford's Arleigh Burke-class Aegis destroyers. As soon as the F/A-18E and F is projected from the deck, it aggressively climbs to approximately 9,000 meters and connects to the pod-equipped KC-135 refueling booms. It fills its internal tanks to 100% capacity before even leaving the sanctuary of the carrier strike group. Now, the truck is loaded and refueled, but it still needs eyes to find the buried targets. This is where the distributed lethality network activates. NIFC-CA demands the absolute separation of sensor and shooter. By breaking the link between the weapon-carrying aircraft and the sensor tracking the target, the Navy achieves unparalleled survivability. The gun does not need eyes, and the eyes do not carry a gun. The 4-hour countdown is rapidly ticking. The theoretical architecture must now transition to violent execution. War does not begin with an explosion, nor with a massive wave of visible aircraft. It begins in absolute electromagnetic silence. To provide the fleet with eyes, a flight of Air Force F-35, a Lightning II stealth fighters, takes off from Allied bases in the Middle East. They penetrate the airspace of the Zagros Mountains under the cover of their radar-absorbing geometry. Their internal weapon base contain only the absolute minimum of aim, 120 air-to-air missiles, strictly for self-preservation. They do not carry heavy strike armament. They act as digital vacuum cleaners, designed solely to absorb data. To maintain their stealth profile, the F-35 has turned off their active radars. They enter strict emission control, MCOM, mode. They fly completely blind, refusing to emit a single watt of detectable energy. The airspace over the Zagros is not empty. It is flooded with resonance early warning radars searching for anomalies. As they sneak through this invisible web of radiation, the F-35A becomes a passive sensor node. The highly advanced AN/ASQ-239 Barracuda electronic warfare system silently absorbs every stray microwave emission leaking from the Iranian defense network. It measures signal strength, calculates time difference of arrival, and triangulates the geographic coordinates of the dormant Bavar 373 and S-300 batteries without ever sending a ping of its own. This critical telemetry is encrypted and transmitted to the satellite architecture via the highly directional multifunction advanced data link, MADL. The enemy is mathematically mapped and condemned to death without even knowing it is being watched. But mapping a target does not destroy it. Data is useless without a kinetic delivery system. The cloud now requires the executors. With a targeting matrix fed into the cloud thousands of kilometers away, the strike group is launched. The fleet of F, A-18E and F Super Hornets completes its aerial refueling and establishes a holding pattern at a predetermined safe coordinate, approximately 1,100 kilometers from the Iranian border. This is a mathematical sanctuary, completely outside the maximum kinematic range of any Iranian surface-to-air missile. To avoid early detection, the Navy pilots turn off their active radars. Deep inside the avionics bay, the fire control computers passively receive raw targeting telemetry streamed from the cloud. The F-35, as silently patrolling over the mountains, feed real-time, millimeter-accurate kill coordinates directly into the targeting brains of the AGM-158B JASM-ER missiles suspended under the Hornet's wings. The shot is fired from a different time zone, entirely bypassing the need for the launching aircraft to ever see the target. However, the moment of release triggers another critical equation. The aircraft must shed its weight and disappear before the carrier's logistical cycle collapses. At the 1,100-kilometer mark, final authorization is confirmed and the order is given. With a mechanical snap, the heavy JASM stealth cruise missiles detach from the pylons, their small turbofan engines instantly igniting to maintain flight. And at that exact second, the brilliant logistical mathematics of NIFC-CA Doctrine reveals itself. The instant the weapons leave the aircraft, the F, A-18E, F pilots turn around and execute an immediate return to base RTB maneuver. They do not push further to confirm kills. They turn their backs on the target and fly directly towards the Mediterranean. Because the aircraft has only traveled a fraction of the total distance, the turnaround time plummets. In the heart of the Ford, advanced weapon elevators operate with frictionless precision, smoothly moving over 800 tons of ordnance to the deck. By rearming returning jets through dissociating the strike distance from the distance the aircraft must travel, the Navy has hacked the timeline. The volume of fire is strictly a byproduct of manipulating time and space, allowing the carrier to achieve its 270 sortie rate without exhausting the crew. The aircraft are now safe. The carrier's logistical loop is secure, but the weapons are now on their own. The digital configuration ends here. Kinetic reality begins. Hundreds of AGM-158B JASM-ERs descend towards the ground. They adopt very low altitude flight profiles, following the terrain at high subsonic speeds. They use the rugged rock formations of the Zagros to physically mask their radar signatures from ground-based interceptors. As the swarm crosses the border, Iranian cyber commands detect the anomaly. They activate high-power GPS jamming systems. Satellite links are violently severed. Navigation channels are flooded with cryptographic noise. An inferior weapon would fail here. The JASM-ER simply changes its sensory input. Its artificial intelligence instantly switches to its internal inertial navigation system. It activates its imaging infrared seeker and autonomous target recognition algorithms. It compares the thermal signatures of the terrain with its preloaded solid-state drives. It navigates purely by geometry and heat. Electronic jamming is rendered mathematically insignificant. Approximately 18 kilometers from the target area, the physical limit of stealth is reached. The immense electronic scanning radar antennas of an Iranian S-300 PMU, two battery cut through the radar clutter. Tracking algorithms lock on. Automated defense protocols activate. Massive 48N6E2 interceptor missiles erupt from their vertical launch tubes. They accelerate to Mach 6 inches seconds, tearing through the rarefied mountain air. The JASM-ER swarm reacts. The formation instantly disperses to complicate the interception geometry. But Mach 6 is unforgiving physics. 3 Vanguard JASM-ERs are hit. They are obliterated by a hypervelocity shockwave of tungsten fragmentation, expanding at over 2,400 meters per second. The composite airframes are reduced to burning debris. The enemy has drawn blood, but they have fallen into a fatal mathematical trap. An S-300 launch vehicle has a strict physical limit. It contains exactly 4 ready-to-fire interceptors. It burned them all to shoot down the Vanguard. But the United States Navy did not send 4 targets. It sent a swarm. While the empty Iranian launchers mechanically struggle to reload their tubes, the sky is already filled with the rest of the strike group. The engagement bandwidth is completely saturated. It is a kinetic energy buffer overflow. The subsequent JASM-ERs fly directly through the shrapnel clouds left by their destroyed wingmen. There is no hesitation. There is no morale to break. They strike the radar antennas and command bunkers with precisely calculated kinetic overlap, ensuring no structure survives. 450. Kilogram-penetrating warheads detonate deep within the concrete structures, collapsing the underground networks. The integrated air defense network is systematically dismantled. The ballistic missile silos are laid bare, their protective umbrella completely erased. The threat is neutralized with exactly 3 minutes to spare on the countdown, and the United States Navy's casualty report indicates 0. Not a single American aviator was lost, because when the fire fell, there wasn't a single American aircraft within nearly 1,850 kilometers of the blast zone. If you respect the ruthless engineering, inflexible physics, and cold mathematics that dictate the rules of the modern world, then subscribe to Border Watch Daily and join our ranks. Now, let's circle back to the paradox that defined this entire engagement. Why did the USS Gerald R forward anchor in the eastern Mediterranean instead of pushing into the Persian Gulf? The enemies of the United States looked at the tactical map and mistook geographic distance for weakness. They staked their survival on the strict limits of jet fuel, the thermodynamic exhaustion of a 4,500-strong crew, and the rigid boundaries of physical space. They believed that distance alone offered immunity. They failed to understand the geometry of modern warfare. Pushing a 100,000-ton supercarrier into the shallow, mined, and highly contested waters of the Persian Gulf is not an act of bravery. It is a tactical error. It places the Navy's most expensive asset inside the enemy's primary kill zone. By holding the line in the Mediterranean, the United States Navy did not retreat. It transformed a distant sanctuary into an untouchable launchpad. It used the 2,300-kilometer gap not as a barrier, but as an impenetrable geometric shield for the forward. The carrier remained perfectly safe, while its kinetic reach, amplified by the Air Force's digital architecture and the autonomous JASM-ER swarm, crushed the Zagros Mountains. This forced the Iranian defense network to stretch its concentration across multiple axes, trying to defend against a ghost it could not reach. Modern warfare has evolved beyond the primal need to look your enemy in the eye before pulling the trigger. Power is data. Power is the cold, calculated logic of keeping your capital ship in a sanctuary, using the joint forces' digital architecture to passively locate targets, and employing a cryptographically secure frequency-hopping cloud network to guide artificial intelligence to destruction. The United States Navy did not overcome distance by stretching its arm beyond its physical limits. It overcame distance by digitizing it. By separating the sensor from the shooter, they transformed a perceived geographical limitation into a distributed lethality network. They proved that when digital integration meets the relentless extrusion of heavy metals from American industrial capacity, the result is the total thermodynamic and kinetic dismantling of the enemy's defensive architecture.